Hello, this is Mr. Hansen. In the last video, we talked a little bit about number systems and we started to introduce I. We're going to talk a little bit more about where I comes from, and we're going to look at rational numbers a little bit more closely, and then we're going to look at powers of I. So those are the three things I want to get accomplished in this video. So first of all, let's look at some of these equations. You might say, oh, these are so easy, and you're right. Let's just think about this, though. A number plus 2 equals 6. Well, you know the number is 4. And look at the numbers that we were already using. 2 and 6. We're working with numbers that are all in the set of natural numbers. So nothing new there. Kind of pretty basic. So we can, with that equation, we can solve numbers that are in the set of natural numbers, counting numbers 1, 2, 3, 4, and so on. Look at number 2. We'd have to subtract 2 from both sides, and now we got x equals 1 minus 2. And if you think about, okay, 1 minus 2, they're natural numbers, but that operation is kind of forcing us to think outside of the set of natural numbers. 1 minus 2 equals negative 1. And so now all of a sudden we are in the set of integers, and that looks like that means integers there, a set of integers. If you looked at number 3, again, an easy one to solve. Divide by 3, and we started dealing with natural numbers, and now all of a sudden we are dealing with rational numbers, numbers that are written as fractions. And they're rational numbers. If we look at number 4, we've got x times x minus 4 equals 1. If we added 4 to both sides, we'd get x squared equals 5. And then we'd have to say what number times itself is 5. We're kind of square rooting that. And so here we have irrational numbers. This square root 5 is an irrational number. Cannot be written as a fraction. And finally, last one, if we subtracted 4 from both sides here, we'd have x squared equals negative 1. And we try to square root both sides, and we get x equals, and this is beyond being an irrational number because it's a negative. You think, what number times itself is negative 1? Well, there is no number that multiplied by itself equals negative 1. So this becomes a complex number, or in this case, the square root of negative 1 is an imaginary number. So now we're talking about an imaginary number that belongs to the set of complex numbers. So the idea is that as people are doing algebra, as they're using properties and operations to kind of get x by itself, these new number systems are coming up, and so we have to deal with ever more complex number systems. And this square root negative 1 is what I is equal to. So with that said, let's take a look at the powers of I. If I had I equals square root negative 1, then I squared, that's just I times itself, equals square root negative 1 squared. And if the square and the square root kind of undo each other, so you're left with negative 1. So I squared always equals negative 1. Now if I had I cubed, we could say, okay, well that's I squared times I, and I is the square root of negative 1. So you might remember I squared we just said was negative 1, so it's negative 1 and I, negative 1I. I to the 4th, you could write it as I squared times I squared. And what is negative 1 times negative 1? It's 1. Okay, I to the 5th, it can be written as I to the 4th times I to the 1st. So I to the 4th we know is 1, and I to the 1st is I, so that equals I. I to the 6th, it can be written as I to the 4th times I squared, and so we know this is 1, and I squared is going to equal negative 1. I to the 7th, it can be written as I to the 4th times I to the 3rd. And again, we have 1, for I to the fourth, and I to the third is negative I. And finally, I to the eighth. It can be written as I to the fourth times I to the fourth, and that equals 1. Maybe you're seeing a pattern come up. Let's skip around a little bit. Let's go I to the 20th. Well, let's divide by 4. That would be I divided by 4, we get I to the 5th. In other words, we're saying if it's divisible by 4 with no remainder, then we get 1 times 1 times 1 times 1. So if it's divisible by 4, we get an answer of 1. Let's do I to the 21st. Well, 4 goes into 21 times 5 with 1 left over. So if there's a remainder 1, it's going to be like 1 times I. So I to the 21st is going to be I. Okay, I to the 22nd. Let's go 22 divided by 4. That's got a remainder of 2. So a remainder of 2 is going to be the same as I squared. It's going to be negative 1. Okay, I to the third. Again, we're going to go 23 divided by 4. That has a remainder of 3. So that'll be negative I. And I to the 24th. Again, that's divisible by 4, so we're back to where we started, just 1. So hopefully this makes a little bit of sense to you. It's kind of a repeating pattern on and on and on. Let's try I to the 70th. So 4 goes into 70, 4 times 1 is 4, 30, 4 times 7 is 28. So we got remainder 2. So this whole thing, the 17, is just 1. And then a remainder 2 is going to be, remember when we had a remainder 2 right here with 22, it was negative 1, or I squared. So it would be negative 1 right there. Hope this helps you understand that a little bit. There's one last thing that I wanted to touch with you on, and they had this in the assignment. How do we know that this is a rational number and not an irrational number? So remember, a rational number can always be written as a fraction. That's kind of the big idea. You can put it on the number line. You can break a number line up into as many pieces as you want, and it can always be written as a fraction. So we're going to try to write these 3 as fractions here. So the first one, it's 0.2 repeating. So I'm going to put x equals 0.2 repeating. And what I'm going to do is I'm going to times both sides by 10. So I have a new equation, 10x equals 2.2 repeating. And then from there, I'm going to subtract the same thing from both sides. So I'm going to go minus x on this side and minus 0.2 repeating on this side. So I'm just subtracting that and that, same thing. And I get 9x equals, the 0.2 repeating cancels out, equals 2. And divided by 9. And x is 2/9. So when you have a repeating decimal, you can write it as a fraction. This is kind of a handy little strategy to do that. Let's look at one that's a little bit more, there's a little bit more to it. So this time x equals 0.47. And I want to subtract out that 0.47. So I'm thinking in advance. I'm going to times by 100. 100x equals 47.47, repeating. Now I can subtract x from this side, and I can subtract 0.47 from that side, and I got 99x equals 47. And then just divide by 99 on both sides, and you get 47 over 99. That fraction can't be simplified. Okay, last one. This one's a little bit trickier. X equals 5, 0.13 repeating. So let's see what we can do. Let's times this, so x equals 5.13 repeating. Okay, I'm going to go 10x equals 51.3 repeating. And 100x equals 513.3 repeating. Okay, notice how multiplied up by tens each time, I'm kind of scooting over decimal place. And it eventually gives me this 0.3 repeating and this 0.3 repeating in both the 10 and the 100. Now I can subtract them out. So 100x minus 10x is 90x, and 51.3 repeating right there. So this cancels out, and 3 minus 5 is, 3 minus 1 is 2, and 11 minus 5 is 6, and 462. So 90x equals 462. Divide by 90, divide by 90, and there we have it written as a fraction. Notice they both end in even numbers, so you could half both sides. This would be 231, and this would be 45. They also have a factor of 3 in there, so you could divide both things by 3. 3 goes into 23 7 times, 2 left over, and 3 goes into 21 7 times, so I believe that's 77. And take a factor of 3 out of this. 3 goes into 4 once. I'll just do it for you. Once, and then 15 5 times. So 77 over 15. Same thing as 5.13. Thank you for listening in. I hope this helps you with any of your ALEKS assignment, and keep working away. We're kind of nearing the end of this unit with quadratic equations. Thank you and have a nice day.